In this lecture, I want to use the localized electron model to just talk a little bit more about pi bonds in particular. So pi bonds, if you recall, are the second and third bonds. So if I have a double bond or a triple bond, I have pi bonds involved. And there are two situations, two types of this indirect overlap that can give rise to pi bonding. And one of those situations is when a p orbital overlaps with a p orbital above and below the bonding axis. So this is common when you're forming a pi bond between two second row atoms. However, there's another situation that I want to kind of differentiate, and that's when you have a p orbital overlapping with a d orbital above and below the bonding axis to make a pi bond. And this occurs when you have a bond between a third row atom and a second row atom. So I want to just point out how this happens using a couple of examples. So let's take C2H4. In C2H4, let me just draw its line bond structure quickly. We already in a previous video have described the bonding situation in this molecule, but we have a double bond, and that double bond comes from the overlap of the 2p orbitals on each carbon. So we have the 2p orbital on this carbon overlapping with the 2p orbital on this carbon above and below the bonding axis. And that's what gives rise to this pi bonding interaction between those two carbons. So that's an example of pi bond forming from the overlap of p orbitals when we have the second row atoms bonded to each other. But let's take a different example, phosphate. Let's draw the Lewis structure for phosphate. So phosphate is PO4 3 minus. And the reason it's PO4 3 minus is because you will find if you try to draw the Lewis structure for it, and you want to make a Lewis structure that reduces the formal charge on phosphorus to 0, you need to double up one of the bonds between oxygen and phosphorus. The remaining oxygens can have formal charges and single bonds on them. And of course, their formal charges, -1, -1, and -1, are what give rise to the overall charge of 3 minus that the anion bears. So what is going on to produce that pi bonds between phosphorus and oxygen in this drawing? You have to think about what's going on here because phosphorus already used its s and all three of its p orbitals. So it used all of those atomic orbitals in the form of sp3 hybrids, right? Because if I looked at this, I would say that the phosphorus has an SN of 4 and is therefore sp3 hybridized. So it used all of it, it's used its 3s and its 3p orbitals to make those sp3 hybrids. And that's what produced the sigma framework, the single bonds in the molecule. So if this produced the sigma framework in phosphate, the only thing left to make this pi bond here, to make this double bond here, is going to be the d orbital. Okay, so the only thing left to make the pi bond is the d orbital. And of course, phosphorus is a third row atom, so it can dip into its d orbitals for situations like this. So this is an example of pi bonding between, we would have 2p on oxygen and 3d on phosphorus to produce this pi bond here that we see between P and O. Only third row atoms can do this. That's very important because if we take a molecule like here, I'll give you an example of a different type of molecule. What about this molecule? I'm just making up a molecule here. Okay, if I have a Lewis structure like this for this molecule here, really what we have is an ion, right? Because the nitrogen has a positive charge here. Now, let me get rid of this hydrogen to make this a little bit more relevant. What if I get rid of that hydrogen? Well, I have a negative formal charge on my oxygen. Can I do what I did up here with the phosphate and move one of the lone pairs down to become a pi bond? Well, I can't possibly do that, right? I cannot move this electron pair down here because nitrogen cannot expand its octet because it's a second row atom. So here, I cannot form a double bond between N and O. So this molecule that I've drawn in green cannot form a pi dp bond. And that means that the structure is forced to retain those formal charges because there's no way I can form a pi bond to reduce the formal charge to 0 on the nitrogen. So that's because nitrogen is a second row atom. So a second row atom can't use a d orbital to form a pi bond in the way that we saw with phosphorus.